to our talk, Kotlin Multiplatform Mobile, from Hello World to Production. My name is Pamela Hill, and I'm a developer advocate at JetBrains. And this cutie, not Tadeas, that cutie over there, is Miss Emma Woodhouse, my little puppy.
And I'm Tadeas. I'm a senior mobile developer at TouchLab. I mostly do KMP. And that cutie, again, is Mr. Arnold Schwarzenegger, the former governor of California.
Yes. So we'd like to customize our presentation for you today to just based on your experience levels with Kotlin Multiplatform Mobile. So if you have created, even if it's a little toy app in Kotlin Multiplatform Mobile, will you please raise your hand? Just a tiny little app, just to see how it works. Okay, great. So we're going to do a little presentation for the folks that maybe haven't played with Multiplatform Mobile, but don't worry. We are going to include lots of advanced content as well, so it will be perfect for just about everybody. So our talk today really is about evolving your app from infancy to maturity, where we're reaching for the stars, the coveted 5-star review, and the editor's choice badge. We'll be covering the following topics. We'll start with the introduction, where we talk about what is Kotlin Multiplatform Mobile and what are the benefits of using this technology. Then we'll talk about how it works with doing a simple code sharing example. And next we'll look at greenfields and brownfields project scenarios and see how it will best work for your team. And then we'll delve into some more advanced topics like publishing and debugging crashes in production. Sounds fun, huh? If we have time, which I doubt we will, we'll have a closing and a Q&A where we can answer some of your burning questions. Now, if you don't get a chance to ask your burning questions, please catch us later. Tadeas is the guy with the lumberjack jacket, and I'm the woman in the room. Anyway. Okay. So let's start with what is Kotlin Multiplatform Mobile. So I'd like to start by talking about what it is as a technology in general. It's a SDK by JetBrains, yay JetBrains, and it was released into beta earlier in October. It allows development teams to share common code between Android and iOS platforms, but it doesn't impose restrictions on non-shared code. This means that it doesn't dictate what you share and what you don't share, especially not what architectures you use. So for example, on Android and iOS, you can use different architectures. So Multiplatform Mobile compiles that shared module that you see there in the middle into platform-specific artifacts, which you can add as a dependency in your app. So on the left-hand side, you see that we've got iOS, and the Kotlin native compiler in that case will compile the shared module into framework files or CocoaPods, whichever you prefer, and that you use those files as dependencies in your iOS app. On the right-hand side, the Kotlin JVM compiler will compile your shared module into jars or AAR files, which you then add and use in your Android app. I've mentioned that you can share code between the two platforms, and that the decision is yours on what you share and what you don't share. But there are common scenarios of code sharing. For example, here we're sharing the data or core layers and the business or domain layers, but we're choosing not to share the presentation or UI layers, and that's completely fine. But we can also go one step further and share the presentation layer of presenters, view models, and controllers. To reiterate, the choice is really, really yours. So what are the benefits of using this technology? Well, firstly, it's about flexibility, the flexibility to choose what is shared and what is not shared. If you just want to share an important piece of complex business logic, you can. If you want to share an important algorithm, you can, and take things from there later. Secondly, it has to do with lowering the effort and cost per feature. So development teams don't have to duplicate the effort that, to ensure that it works consistently and correctly on both platforms. And this is going to drive down both development and testing costs. Shared code also ensures consistency amongst platforms. So I've seen so many times that an Android developer and an iOS developer have slightly different understanding of a particular requirement, and then they'd start developing slightly nuanced implementation differences too. So that's a less than ideal situation. So Kotlin Multiplatform Mobile really does give you flexibility, lowering the cost, and consistency amongst platforms. Now, because this is a little bit, not a beginner kind of talk, but I want to discuss a little bit on how it works practically. Just for those folks in the audience that haven't seen this technology before, we're not going to do live coding because of, as exciting as live coding is, especially for me when I'm standing there sweating in front of you. But this won't be live coding because of the time that is actually required for the dependency and platform downloads. It takes a while. And I don't know about you, but ain't nobody got time for that today. So these are the tools that you need to get started with sharing code on Android and iOS with Multiplatform Mobile. You need Android Studio with a Kotlin Multiplatform Mobile plugin. You need the Java Development Kit, or JDK. And you need Xcode on macOS from the App Store because you're going to be coding some iOS stuff on Xcode. So there is also an open source tool called KDoctor, which you can use to verify whether your environment's set up correctly. I know it's actually very, very handy, and it really, really helped me to set up my environment correctly when I was doing it for my M1, which was quite tricky. So JetBrains has this plugin for multi-platform mobile development, and you can get that from the plugin marketplace. And it's just going to make your development for multi-platform just that much easier by creating a new platform, multi-platform project or library, write shared code once and then use it from Android and iOS, and also run and debug your app on Android and iOS targets from Android Studio. So you're able to run an iOS app from Android Studio. So our example today is just a little program that shows us, and it's basically the default example that you get when you use the Kotlin plugin generator to create a new multi-platform mobile app project. And it shows just on the left-hand side for Android, it shows hello Android 31 for my Pixel 4 emulator, and hello iOS 15.5 for my iPhone 11 emulator. It's a little old, but don't tell anyone. So 31 is the SDK version for the Pixel 4 emulator, and 15.5 is the system version for the iPhone 11 emulator. So I've taken some screenshots just to show you how it works. Using the new project wizard, we can select Kotlin Multiplatform Mobile app to create that app from scratch. And then we have to provide some information to the plugin, like what is the project's name, what is the package structure, and what is the minimum SDK supported by Android. Next, we have to give a couple of names to different things, like the Android app, the iOS app, and the shared module. You can keep it like that as it is, because it's pretty good default names. So in this screen, you'll see the bottom option. We're also sort of configuring how to distribute our code to Xcode using either regular framework files or CocoaPods. Now, a regular framework file is just so much easier to start with, but CocoaPods is where you actually eventually want to migrate to. So once the plugin has done its magic and all the stuff has been downloaded, as I mentioned before, it takes some time, so it's not really, really magical. This is what it is going to look like. So we have Android app under Android app, iOS app under iOS app, and remember we configured these names in the previous step. And we have a shared module jam-packed full of Kotlin code. There's 3 subdirectories in that module. There's common main, where all our shared code is, and there's 2 directories called Android main and iOS main, where all our platform-specific integration code is. Now, you might be wondering, did I just really say that shared module consists just of Kotlin code, even the iOS parts? And the answer is yes. It is all Kotlin code, even the iOS parts. And maybe you were wondering, what is this platform-specific integration code? Well, it's basically just gives you the platform-specific functionality, like it gives you access to the Android and iOS APIs, which is pretty powerful. So this is how it all kind of fits together. So the Kotlin Multiplatform Mobile stuff is in that pretty, which doesn't look so pretty on the screen, but it's like a rose color. Did you know that there's a Kotlin brand color called rose? Now you do. So the shared code is in the greeting file. It's just an example, so it's pretty simple. But the shared code is in this greeting file. And if you look on the left-hand side, the iOS app uses that shared code, which in turn calls into the iOS shared code, which accesses the iOS APIs to get the system name and system version. On the right-hand side, the Android app goes ahead and uses the shared code, which in turn calls the Android's shared code, which in turn calls the SDK, or gets the SDK version from the device that it's running on. So if we have a look at the greeting file, we're now in common main, and that's, to reiterate, that's where all our shared code is. It contains a greeting class that has a property called platform, and we get this value somewhere from a top-level function called getPlatform, and we'll look at that on the next slide. But we also have a function called greeting that returns hello platform.name. If we look at common main's platform file next, we see that we're defining this interface called platform that just has a name property. And we have this getPlatform function that we just talked about in the previous slide. It returns something of a type platform, but there's no implementation. And the reason for that it's okay to have that, is that there's an expect keyword in front of it. Now, expect is a Kotlin keyword that tells us that the code that we're actually looking for is somewhere in the platform-specific functionality, that platform integration code. Where is that? Well, it's in Android main and iOS main. So here we are in Android main, and we're looking at the platform file. Here we define a class called platform, and we override the property name to give Android followed by the SDK version. So here we're accessing device-specific information. We also define a getPlatform function, a top-level function, that returns an instance of this class. And there's a keyword actual in front of it. Now, this is very, very important. Expect and actual work together. So what it's basically saying in this case is that if you were looking for the actual platform-specific implementation that you expected in common main, well, here it is. Similarly, for iOS, we define a class, and we return that class in the getPlatform function. It's also preceded by actual. So they kind of follow the same pattern. But in this case, we're using iOS-specific classes, functions, and properties to query device information. But how does this code actually get on the screen? Well, here we are in Android app. So we're looking at the Android-specific stuff, and we're looking at the main activity. So in this class, we're using activity, for those that don't know Android very well. It's basically just a screen, and we're using Jetpack Compose here to define our screen, and we're passing the function called greeting.greetingResult in to a text composable, and that's how it gets on the screen for Android. But how does it get on the screen for iOS? Well, this is a simple Swift UI application that we can define in iOS app. So this is under iOS app Swift. And we're looking at the content view here. We're going to drill down into content view because there's not really anything specific to the screen in here. So in content view, we are creating a constant called greet, and we're assigning the value greeting.greeting to it. And in the body of that view, this content view, we're just creating a text element with that constant inside of it. So when we actually run this application in Android Studio, we can use the run configurations for Android app and iOS app to run the application on emulators and real devices and see for Android, hello Android 31, and for iOS, hello iOS 15.5 on that iPhone 11 emulator. So just to summarize, what did we just do? We created some shared code. Imagine if the greeting wasn't hello something, it was instead a really complex piece of business logic, maybe an email validation regex or something like that. And then we used that shared code from both Android and iOS that was in the main activity and content view. And then lastly, we used platform-specific functionality from the shared code. That was the platform files that we looked at. So on to use cases. So this is ramping up to sort of intermediate level KMM. So Kotlin Multiplatform Mobile can be used in a variety of use cases, from new to existing projects. And we're going to have a look how we can best share code between Android and iOS to make sure that it works for your team's specific needs. Perhaps your team is creating a Kotlin Multiplatform Mobile project from scratch. And this, if you use the Kotlin Multiplatform Mobile generator for the app, it will generate a project that looks very much like this. So again, the rows is just a Kotlin Multiplatform Mobile module. And we'll have an Android app in Android app, an iOS app in, it's just a simple directory, and we'll have a shared module. So the shared code is under common main, and the platform-specific integration code is under Android main and iOS main. So we like this structure a lot because it basically encourages your whole team to participate and collaborate into creating the shared code. So everyone will be working on the same Git repo, for example, the monorepo, and we'll all be working together on that shared code, so everyone will be contributing to that shared code. And what's also nice is that it's easier to debug on Android and iOS in this kind of structure. But something to remember is that you're going to have to be very careful about versioning, like you'll have to version Android and iOS sort of separately. But perhaps you have an idea of your Greenfields project, your new project, and you maybe have a few feature modules that you'd like to start with in the beginning. So what you can do is you can create some feature modules like here I have analytics, validation, and formatting, which are ideal use cases for something like a technology like multi-platform mobile. And in this case, you would make iOS app a Gradle module that transitively depends and possibly exports those feature modules that I just spoke about, those bottom 3 rows ones. So the iOS app needs to be exported to an XCF framework file. And the reason why you only want one XCF framework file that you basically send to Xcode is that whenever you do that, you are basically sending across the whole Kotlin standard lib. And if you do that for each module each feature module, you'll be increasing your iOS app binary size significantly each time, and you don't want that. So, and another reason is that the classes between XCF frameworks aren't exactly compatible. But of course, not all projects can be brand new, and that's the brownfield scenario. So sometimes you have existing and separate Android and iOS apps, and that's perfectly fine. What you can do is you can create a shared module in your Android project, and there's a new module wizard that you can use to do that. So that new module wizard will also help you define how you're going to distribute to Xcode, your shared code to Xcode. But this doesn't really scale very well. So what can you do if like your shared module gets really big? In that case, you can, again, create some feature modules, but you also want to create a shared KMM module, which will depend transitively on the feature modules. Again, the reason for this is that you only want one Xebia framework for binary sizes and for compatibility's sake. So I have a few suggestions if you want to add multi-platform mobile to your projects. First, I want to say, start small. If you would just begin with a simple function that's in your shared module, there's going to be enough work for you to do already. For example, if you'll have to look, is everything still working locally on your CI/CD pipeline? Is everything still, is nothing crashing horrifically on production? And this will give your stakeholders and the rest of your team that sense of comfort, and that you'll get more buy-in from your team if everything still kind of runs okay. Next, keep your shared API simple. Your iOS team will thank you. You will thank you, because there are currently some limitations between Kotlin and Swift and Objective-C, using things like sealed classes and enums and default arguments impossible. So don't try to get too fancy, too fast. And thirdly, think like a library developer. So I recommend having a look at Joshua Bloch's How to Design a Good API and Why It Matters presentation for more guidelines. But for now, I stole a couple of his points. And the first point is implementation shouldn't impact API. So I shouldn't be able to guess what technology or library you're using in the background to implement your API. Minimize the accessibility of everything. So the magic keyword here is internal, where you're going to use internal liberally without, aside from your public API. And this is also going to do sort of magic for your iOS app binary sizes, because it will reduce that significantly. And lastly, coexist peacefully with both platforms. Don't just think about Android, also think about iOS. So learn from your iOS developers in your team what good iOS code looks like, and then implement an API that will encourage them to write great-looking code. So something that I wanted to mention was that both JetBrains and TouchLab, and if you want to take a picture of one thing today, here it is. Both JetBrains and TouchLab are working on solutions for Kotlin and Swift interop. So that link over there is the closed alpha for that TouchLab has for their Kotlin Swift interop closed alpha, which is really marvelous. So JetBrains' side is still sort of in the works, but TouchLab has this amazing closed alpha program that they're working on already. So this is the enrollment one for that one. So I would definitely check that out if I were you. And with that, I'm going to hand over to Tadeas.
All right. So let's talk about publishing. So now your app is done. You have something that you want to show the world. You want to publish it on the Play Store and App Store. I won't really cover Play Store because I expect that you probably know how to build an APK, but not many of you will probably know how to build an IPA, which is a package with the iOS app. One thing to note is that with KMM, you're really building a regular iOS library, and you package that into an iOS app. So the result is just a regular iOS app that you can publish. And for that, you can use basically any tutorial that talks about publishing to the App Store. So I've included two of them here. One is from Instabug, and the other is from Apple themselves. But I do want to cover it at least a little bit. It's a deep topic, so I'm just scratching the surface here, but I want to look at like the most weird things that might surprise you as an Android developer. So these are kind of scary words: identifiers, certificates, blah, blah, blah. Thankfully, today in the year 2022, you don't really need to think about them as much as before, and you can instead let Xcode do that for you. But if you do need to tinker around or manage it yourself, on the developer.apple.com/account, you can go into these basically 4 links, certificates, identifiers, and profiles, and manage it yourself. Otherwise, this would be how you configure it in the Xcode to take care of it for you. Unfortunately, it's not all sunshine and rainbows, especially if you have more people on your team, because there's like a limited number of certificates you can have. So then your Xcode will take the certificate and cancel the one that your colleague has, and so they can do publishing, and only you can do it, and all this is weird. But it does really work if you're a single developer publishing, or if you're like, I think the limit is 2. But I do want to look at the scary words, as I like to call them. Let's start with identifiers. So identifier is basically like a bundle name from Android. I hope that's the correct term, which is a unique identifier of your app in the App Store. Then we have certificates. So certificates are different from Android, where on Android you have the key store and you sign the APK, and then you upload it to the Play Store. On iOS, you need to create a certificate request, and you do that in the keychain, and then submit that through, like, again, Xcode does that for you today, but previously you would submit that to the developer.apple.com, and you would get a certificate that you would then sign the app with. The third thing is entitlements. So every time your app needs to do some privileged action, for example, push notifications, right? That's something that is outside of your app runtime, something that happens automatically because your server sends a push notification, for example. You need to have an entitlement for that. You need to tell the system that's something you want. And then the last thing is provisioning profile, which kind of ties it all together. It basically assigns the certificate to an identifier and entitlements to it, and tells the system that this is trustworthy app that you can install on your device or on public devices. So before we go to the publishing itself, you really want to disable bitcode in your KMM framework. To do that, you add the embed bitcode equals to your build Gradle file. You shouldn't need to do that because the Xcode usually can remove it for you. The reason I mention it explicitly is that it will make your builds slightly faster if you don't have that. And when I say builds, I mean the Kotlin framework builds. Now, I hope that all of your apps, if they access the network, use HTTPS or some other encrypted channel. Unfortunately, the US government requires all encryption to be declared unless it's exempt. So if you want to save yourself time and doing manual, like, yes, this is an exempt encryption in the App Store Connect website, you want to add that into your info.list in the iOS app. Again, it's not really mandatory to do this, but then you will have, like, for every build, you have to go into the App Store Connect and say, yes, this app is using encryption, and yes, that encryption is exempt. Now it's time to archive. One funny thing is that you need to make sure to select this target before you go to archive, otherwise it will be grayed out. When I started with iOS, I've seen, like, oh, you just go and do archive, but it was grayed out. How do I archive when it's grayed out? So just remember to select this first, and then you go to product and archive, and it will build your app. Once that app is built, I'm gonna go back real quick. Once the app is built, it will open like an organizer, which allows you to distribute it to the App Store. I don't have a screenshot for that because I can't show you my apps, but it will open up for you, and there will be a huge blue distribute button, and then you just go, like, you install something on your Windows, just next, 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 accept terms, whatever, and then it's done. So now that your app is in the App Store, you probably want to test it either internally or externally. You can use TestFlight for that, which is the probably easiest. It has some limitations, but it's good enough. For internal testers, those are the people you have in your company and who have user accounts in the App Store Connect portal. So for those, you can just submit the build. They can install it. They will get an email. They will install it on their iPhone. All good. For external users, you need to submit the build for review. So this review is done by the App Store team. It's not as complete as like the release review, but it's still something you need to keep in mind that it can be just an empty Hello World app. They will reject that even for the public beta test. The good thing is, once you submit that into the test flight, once you do all of that, you're good. For that version, you don't need to do any other review for that public test. Now, when you want to go and release publicly, make sure to review guidelines. They do change from time to time, and be prepared for rejections. So rejections on iOS are different than on Android. On Android, like, you really don't want to get rejected. I don't know, maybe that changed now. I haven't released an Android app for a while. But on iOS, that happens all the time. For example, if you mention Android anywhere, which for a DroidCon app, which has all events about Android, is a little difficult to not do. But just make sure that Android doesn't exist for Apple. Apple's like, why would you lie? Why would you say that there's Android? There's no Android, right? So don't mention it and you'll be fine. Not in screenshots, not in description, not in what's new. You can't even say, oh, we now have the same features as in our Android app. Nope, there's no Android. And now let's review, what the? Sorry. Now let's review debugging crashes. Again, not looking at Android. What's happening?
It's not me. I'm not touching anything.
Anyway, I'm not looking at the Android issues. You're the experts. You're going to figure it out, I'm sure. On iOS, it's a little bit different. So if your apps are anything like mine, they crash a lot. And the one thing that you need to know that's different is errors and exceptions on iOS are different than errors and exceptions on Android. So on Android, or Kotlin really, errors are basically non-recoverable things, and exceptions should be recoverable. On iOS, in Swift and Objective-C, is the other way around. Exceptions are not recoverable, and you should never recover from an exception. If you do, the app is probably in a state where it will crash later on with something really weird. Whereas errors, or an NS error in this case, that's recoverable. You want to catch that, you want to make sure that that's all fixed before you continue. So how does Kotlin Multiplatform map into, let's say, something like Swift, right? If you look at the left, we have two methods that, when called from Kotlin, were completely the same. They both throw illegal state exception. You can call them both. You can catch around both of them. It's the same thing. But on the iOS side, they will translate into something like the first one will be throwing, and you can catch the error, whereas the other one will just crash your app. And the only difference is annotation at throws. So make sure that every time you want to handle exceptions on the iOS side, thrown from the Kotlin side, you need to make sure that you have the at throws. Even though there's no such thing as checked exception in Kotlin, they kind of are when translating to native iOS. Now, what about the stack trace? So in native, there's not really a stack trace you get. When Kotlin fails, you will get something like Kotlin abort or something like that, and then it's like 8 frames and that's all you get. So you need something like crash chaos or NS exception kit. Include that as your dependency, and you will get stack traces in your Crashlytics, Bugsnag, whatever. It still won't, like, it's just an added stack trace. It's not really the stack trace of the crash, but you will get the information you need. Now, when we have the stack trace, let's try and reproduce on iOS, right? So you can either use a device. If you don't have the device, iOS Simulator will work well. So reproduce it on iOS, see what steps you need to take to crash the app. Then try and write a test for that. Hopefully you have a test suite that you can do that in, and you're not like me where I don't. So write a test that's red, and then go and fix it. It will make it easier for you to debug the issue. It will make it easier for you to fix the issue. If you don't have the test suite, that's fine as well. Try and reproduce it on Android. On Android, you have the full might of the JVM behind you, and you can do expression, you can debug with stepping and expressions and all of that. That's not the case in Xcode. Unfortunately, Kotlin native isn't currently great in debugging in native, so if you can't really get it reproduced on Android and then fixed on Android, you have to go and debug in Xcode. To do that, there's this plugin, I would say, Xcode Kotlin. It's something that you install. You need to kind of reapply it with every new Xcode update, and then you kind of can debug your Kotlin code when you add it to your project. It's not great, I'll be honest. You can do breakpoints. They sometimes stop, not necessarily on the place where you put them on. This one I've kind of simulated. This one would stop on the right place, but I wanted to show that it's not always that. Unfortunately, for example, here when we have a suspend function, you can see that here, where you have the frame variables, so everything that's available in that frame, you don't really see what you expect to see. You do have the context of the coroutine. So that kind of doesn't help you. You can get out of that, and it's weird. So you can have to go and do print lines. So we get back to PHP days, kind of. Just make sure to add a bunch of print lines in one go, because the compilation times of the Kotlin iOS, it takes time, and I guess it happens to me often that I'm like, oh, this is not my doing, or I'm just like hitting the screen. Where I add just one print line because I know this is the place I need to debug. I put it there, I recompile, I wait a couple of minutes, and then I'm like, nope, that wasn't the place. I need to add more print lines and do this thing again. So just try to add as many of them as possible. You can always delete them or just reset your Git repo, right? So let's look at what you should take away from this talk. First, Kotlin Multiplatform Mobile is powerful but challenging. It's something that you can do a lot in. You can decide, it's very flexible. You can decide like how much you want to share, how much you want to keep in native. For example, you can do UI all in native. But now, if you try the DroidCon iOS app, you can see that there's a iOS compose that you can run, and you can have even the iOS shared. But it's challenging. You really need a skilled team to set it up. The build process isn't all there. It's beta. It's gonna get there. Just give it time. Try and use it. That's what I'm trying to say now. Use it now. It's ready. Even though it's beta, it's ready to be used. It's not great experience in some cases, but the overall experience where you can just write things once and then run them, it's kind of like the old JVM, right? Once, run everywhere. So hopefully that helps. You can find our slides and resources on these 2 QR codes. I'm going to step in the middle of it so you can take pictures. And thank you.